Hi everyone, welcome to lesson 2 on the matrices topic. This particular lesson is about modelling practical situations with matrices. Remember to record the notes as they appear in these slides into your workbook for future reference. So let's start off by showing you there a network diagram on the right. You'll be familiar with this from our Jumpstart topic on networks and graphs. There we've got 3 vertices, points or nodes, whichever way you want to call them, and they're joined by lines. We call those edges. And they just show the connections. It might be like a road connection or something like that. Now, this information in a network diagram can be recorded in a matrix. And in that situation, we call it an adjacency matrix, as we saw in the networks topic from semester 1. So I'd suggest maybe take a pause on this slide now and make sure you get that diagram and record those notes before moving on to the next slide. Okay, so this is our first worked example, and I've said there you can try it first or by hitting the pause and having a go. But for others of you, I'd suggest just go on to the next slide and you'll see how we start to build a matrix. So let's just have a look at this. We've got 4 cities which are represented by A, B, C and D, and it shows the way to travel between these cities. Typically they'd be roads or highways, something like that. Now I've asked you to build a 4x4 matrix to represent the connections between these 4 cities, and you'll see as we go on to the next slide how we might go about that. So the people who are going to have a try now, I would recommend drawing up a 4x4 blank matrix, having A, B, C, D along the top for your columns and A, B, C, D down the left-hand side for your rows. So have a go and pause the video here, or otherwise click on to the next slide where I'll talk us through how we do that. Okay, so for those who've had a go, or those who have just drawn down the diagram, let's have a look at how the matrix is formed. So I said we had to put together a 4x4 blank matrix, and then the hint was to put the letters A, B, C, D across the top, and then for the columns, and then down the left-hand side for the rows. So once you've done that, you're looking to see whether there's a connection, a direct connection between each of these respective towns. Now between A and A, we say 0 because unless there's a loop here, then there's no direct connection from a town to itself. And you'll see that follows down this diagonal between B and B, between C and C, D and D. So the next one is to have a look at what's the connection between A and B. Well, there's one direct connection, so we put 1. And likewise, we have A and B on the matrix being connected here. So again, that has a 1, and you'll see that effectively that's mirrored across this red diagonal. Going further along, we're looking at what's the connection between C and A. Well, there's no direct connection, so we put a 0. All right, and down here you'll see that the reflected image across the diagonal line between A and C, it's also 0, because again it's the same as C and A. And we continue that on throughout the whole matrix until we've completed it. So for instance, just to quickly have a look at, say, between A and D. Well, A and D is just here, and we see there's no direct connection, so that's a 0. And that also appears over here between A and D. Make sure you've recorded that into your workbook, the diagram and the matrix. Okay, this is our second and our last worked example, perhaps a little bit harder. And again, people are welcome to pause the slide here and try and draw up the matrix and also answer the questions, or you can just click on to the next slide where I'll talk through the answer. But just before we do, let's just have a quick look at this diagram on the right. There are 5 towns, A, B, C, D and E, and they're connected by the roads that are shown there. So a bit more complex than the previous one. The first question was asking us to construct a matrix. Well, that's an adjacency matrix, which we can do, and you'll probably already recognize that that's going to be a 5x5 matrix because we've got 5 towns. Then a couple of subsequent questions. One is question 2, which town has 2 connecting roads. We're going to look for the element of the matrix that shows that. And question 3, we're going to look at what the sum of the values in the 4th column of the matrix represent. So either you've had a go and you can compare your answer here with the matrix shown, or I'll briefly talk you through what I've put together. So I started off with a blank 5 by 5 matrix with A, B, C, D, E on the columns across the top, and down the left hand side those same A, B, C, Ds for each of the rows. And I've gone through like I did in the last example 1, whereby I was looking at what connections exist between each respective town. Now you'll notice again on this diagonal bar marked by the red dotted line, they're all zeros because there's no direct connecting road from a town to itself. We'd see a number in there if we saw a loop, for instance, but they don't have that, so it's just 0. So going out, let's just pick one between here, between B and A, we see that there's one connecting road, and that's shown here from B to A, one connecting road. All right, and you'll see again over here is it's effectively the reflected I guess element. Between A and B we have the 1 here as well, so those two are the same. Now a little bit further across, let's pick between, I'll pick this element between A and E here, which is the same as the one over here between A and E. Both are 0, and that's because there's no direct line straight from A to E. We have to go through another town to get to it. So that's why those are both 0. Now let's just have a look between D and E, because that's interesting. We see between D and E that there are 2 roads, and effectively 2 different ways to go directly from between D and E. So if we look up on our matrix D and E, you see the number 2. Likewise on column E and row D, we have the 2. So again, we need to see those effectively mirrored across the diagonal. And they're both 2, representing that there's 2 connecting roads. That effectively answers that question 2. And if we were asked to say which element that was in answering question 2, we typically say that that is at element of the matrix, if we call it little a, 4, 5. Some people might say 4, 5, but effectively means row 4, column 5 is where we see that element, or it also appears in row 5, column 4, and that's why we see it there as 5, 4. So that defines the element. And the final question, the sum of the values in the 4th column. Let's have a look at the 4th column, column D. It's got a 1, it's got a 1, it's got a 2. They add all up to 4, and that represents the fact that there are 4 roads that directly connect to the town D. Well, let's just go and have a look at town D, put our cursor over that particular vertex, and we see that there's 1, 2, 3, 4 roads that connect them. Thanks for watching.